So once again, the randomize comes in very handy when trying to randomly generate sizes for these trees. So if I go in and copy paste, again we have an integer type as our output at the moment, but if I connect, we automatically get correct data typing. The tree size goes away completely. That's because the min max is 0 and 0. So let's go and set the min tree value to something reasonable. I think we were using a value of maybe 10 and 20, so we get some pretty tall trees and some pretty small trees. Let's go a little bit larger here. These trees aren't looking too bad. They're looking at maybe 20, 30 feet tall. Let's give them a little bit more height. These look almost like second growth. So I'll go in and maybe change those values here. Let me make sure I've got the right randomized value by range up. Let's go with, say, 20 and 30, or maybe 20 and 50. There we go. This is becoming a little bit more dense now, which is kind of what I'm going for. The other thing that we could do as well is even randomize the scale of the trees as well. Maybe I'll even paint a few trees in on this side of the tracks as well. There we go. So we're just kind of filling this whole area in. We'll thin it out a little bit. Okay, I kind of like how that's looking. If we wanted to go in and adjust the size of the trees on a per particle basis, the next thing we'll look at doing is obviously modulating that. But we're going to want to extract the X, Y, and Z axes and randomize those separately so we can have some thicker trunks rather than just dealing with the scale as a whole. So if I jump back in, I'm going to go and set the particle scale, and you'll notice that there's only a size attribute here, which is adjusting the X, Y, Z of the particle uniformly. We can go in and basically layer in on top of this. If we look at our particle task setters, one of the set options is to set the scale, which is setting an XYZ vector. If I double click, it sets the particle scale to 100%. So if I set that in there, it's taking the size as is, and we can now multiply the size, and of course our size is being driven by this random value between 20 and 50. So it's basically multiplying on top of that. So setting the particle scale will keep the original scale that we have, and if I was to go in and thicken the trees out, we can get small little variations there as well too. So that's kind of neat. So I'll set these back to 1, and we'll go in and extract the individual XYZ values for the particles. So what I need to do is actually do a 3D scalar. I need to actually get some scalar values and convert them to vector. So let's go and look for scalar, and we'll look for a scalar to 3D vector, and this is found under the conversion nodes. If we look under tools, conversion, there's all our conversion nodes from going color to grayscale, Euler to quaternion, and in our case we want to go from a scalar value, 3 floating point values, to a single 3D vector. So we get that. Now the problem here is that the default scalar values are 0, 0, 0, so we'll just return them back to 100%, and then we can go in and just randomize the X and Z values and leave the Y value alone, because we already have a randomized height, which is looking pretty good. Now I just want to slightly randomize the thickness of each of these branches. So I'll look for another randomize node, go and copy paste. So we have a max 0 and 2. As soon as I plug that in though, you can see it reverts back to 0. And the reason it does that is because we're actually changing the data type, so we might not even want the same values when we change data types. I'll copy and paste that and use it for the Z value. So now we have no trees at all, and the reason is because the X is randomized between 0 and 0, and the Z is also randomized between 0 and 0. If we bring those back to 1, we rebuild our original tree line, and I'll pin both of these down. I'll bring this one up as well. I'll choose a random seed for both of these that's different, so even if I have the same values running for X and Z, they don't use the exact same distribution over each particle. There we go there. So now what I'll do is just do some small changes. So maybe actually we'll use a min of, say, 0.75 and a max of 1.4. So get a little bit of breakup there. And then on the side here, we'll use a min of, say, 0.6 and a max of, if I use 2, that'll be just a little bit too thick. So I'll go to maybe 1.5. Okay, that's actually looking pretty good. I might even want to go in at some point and make this a bit more random. I do notice that here and there, there's kind of a line to the trees, so I can just kind of remove some trees here just randomly so there's not too much competition. And I can also reduce the number of particles as well. So I'll just jump back in here one more time to the emit compound. And I'll reduce the number of trees from 2,000 to, say, 500 would be too few, so let's go with 1,200. Alright, so that's actually looking kind of the way I need it to look right now, considering that this is the first line of instances. The second and third line, of course, will make up the smaller high-frequency bushes along the periphery of the houses and maybe along the roadway as well. So our first instance tree line is accomplished. Looking pretty good.